Thank you, Daniel.
Hi. Yeah, it's me again. I see a lot of fresh faces, which is quite great. I see a lot of known faces. So my name is Daniel Wagner, and I am a researcher at the DE-CIX, at the research department of DE-CIX. And today, this talk is not going to be as funny as the one on Monday, but this is a rather technical one. I'm going to present the product that I built at DE-CIX, which is called the IPFIX Export. And what all of this is about, I'm going to show you in the next couple of slides. First of all, this is a free service for all of the customers at DE-CIX Frankfurt so far. And it is all about receiving the IPFIX subset that belongs to your interface, or interfaces, if you have multiple of those. So what's the motivation of all of this? So this product I was asked to build was actually a request by the customers. Lots of customers were asking for their subset. They wanted to look into their traffic insights. And so all of this came along. What is specifically interesting for the customers is that the vantage point of the IPFIX generation is different from your own router. Because if your own router has a saturated link, you will only see what actually arrives at the link, but not actually what's crossing our forwarding core. So the vantage point is different than from what you could have with your router. In addition, if you use our product instead of configuring something on your router, you do not need to touch your router's configuration. Maybe your router is just not capable of doing such things. And if it is capable and you configure it, you might still want to use our product because it has no load on your router. So it's about a data export. We need to get something from A to B, and we are using the IPFIX protocol for this. The IPFIX protocol, this stands for the Internet Protocol of Flow Information Export, which supports theoretically 491 different data fields. So what is being carried by the protocol itself can be chosen by you. And the fields that we are exporting are the most relevant ones, I guess. It's like source and destination IP and MAC addresses. It's the transport ports. Kind of all of the information about flows that are crossing a platform. I put a screenshot here that shows exemplary fields that we are exporting, which is an actual screenshot, and I redacted all the sensible information. So how does the receiving side know how the packet is structured? Because as I said, you can build this up yourself. And we decided to build it up in some way. And how we built this up, it needs to be transmitted to the other side in order to make it understand the kind of data format that you're exporting. And this is where the templates come into play. I marked them somehow like a yellow packet in a big stream of blue packets. Blue packets are carrying the actual data, and the yellow ones are the templates. And the templates kind of explain to the other side how to read the blue packets. As you can see on the screenshot here, there are multiple flows in a single packet, so they are wrapped into sets. On this screenshot, there are 14 flows being packed into one packet, which introduces kind of a difficult thing that I will dig into later more. So our overall architecture, how does this look like? On the very left, you could see the switches. These are the production switches of DE-CIX, which do packet sampling in a rate of 1 by 10,000. And based on the packets that are being sampled, flows are generated. What I mean by flow generation is you aggregate the packets that have been sampled into flows for 15 seconds, and if there's no more packet being sampled for this time, the flow information about this packet is being exported. But if you capture more and more packets that belong to the same flow, after 60 seconds, of course the flow is being exported and a new one is generated if there's still more packets to be seen. That's what happens on the leftmost side. Then this kind of IPFIX information from the production switches is being exported to my backend, to a virtual machine that I will be telling you more about later, which receives the one big chunk of IPFIX data that is being generated. Then it preserves the stateful piece of software that keeps track of all of the requests from the customers, where they want to have the IPFIX data being exported to. And then I do some filtering for the MAC addresses that belong to the customers, then encrypt the traffic, and then send it through the internet to the right side where the customers are. So the customers need to set up some kind of IPFIX collector that I will be showing you later also. The customers on the right, they can use our web interface to trigger all kind of these exports. That's the front end that I was referring to. It's the front end. Earlier it looked like more simple, and then there was the new portal being launched of DE-CIX, and since then it looks a bit more difficult, at least for me. And if I'm not mistaken, actually this is not the right screenshot I put here because I don't know what the front-end web dev guys did, but you will find it. I should update this later. However, the procedure should be very easy. It's because if you're logged in, the system already knows your MAC addresses, so you cannot get the data of other customers, and you enter your target IP address to where you would, to which you want to have the IPFIX data being exported to. You hit submit and see what happens. So I was referring to one big, large chunk of IPFIX stream. That is quite a challenge because this big IPFIX stream that we receive from the production switches contains in a single packet multiple flows which belong to different customers. So what I need to do is I need to dig through all of this IPFIX data and filter this for the single MAC addresses that the single customer has requested, and then regenerate a new IPFIX stream from that, and this is then being encrypted and exported. Another challenge is that customers might have multiple MAC addresses, so there are multiple filtering instances, but they should be passed to the same encryptor in order not to block too many transport ports outbound. So this is the challenge we had basically here. And how to implement this, there were multiple decisions or ways to go. I call this the design space that I was confronted with. There were multiple different ways to go, ways to implement this kind of stuff. The first approach I call is the all config, which is one big config which is capable of filtering for basically any customer MAC address, but this had the downside that if a MAC address changes or new customers come into, I would need to reload this kind of config into our Vermont instance. Vermont is the versatile monitoring tool, some open source I got from GitHub, which is capable of rebuilding IPFIX streams, so I did not have to do this all by myself. The problem is if I reload the config, the Vermont instance is being turned down and coming back up again after a couple of seconds, which means that there's a disruption to all running exports. So this was a no-go. Same as for the config on demand. That is not as a config that is not capable of all of the MAC addresses and filtering instances, but it is being generated as a new filtering instance is demanded, which in the end turns up with the same problems. That means that Vermont needs to be restarted, and we've got a disruption. So what I went for is the fully dynamic approach, which I'll be explaining later on. Here's a short wrap-up of how this looked like, and as I said, that if there's an interruption, the red fields, that means that there's no way that I want to do this, because I don't want any customer to shut on and off any exports and eventually keeping all the other customers from getting their IPFIX data. The full dynamic approach, it introduces some kind of an export delay, but I think this is something not too bad. It's about 1 minute, and as you have seen, that the lifetime out for IPFIX flow is 1 minute also, so I think this delay is not to be considered, at least for long-living flows, but after 1 minute you should have your data. And what's with this export chunking and cleanup that was also introduced, we will see right now. For what I did is I created a dumper, a Vermont dumper instance, which takes this huge IPFIX data from Frankfurt and dumps it into files. The advantage here is that these files can be read by every process in parallel, more or less, and every process reads every data. Incoming UDP data, when it's picked up by multiple processes from the socket, means that first come, first serve, and the other processes would not read all of the data. So that's the way that I went for, and that's the reason why I have to do some cleanup, so the dumps need to be get rid of afterwards. And that's the chunking that I was talking about. So now we've got multiple files which contain all of the data, all of the IPFIX data. And I've got the request manager, which takes care of all of the requests that were incoming, which will then dynamically instantiate for every IPFIX export that is being requested a MAC filter. All of these MAC filters, these are Vermont instances. They read all of the dumps and then pass it to the DTLS wrappers. So they're taking care of the encryption because we are exporting sensible data. So there's no way we will not want to encrypt your data. All of this procedure, it introduces about a delay of about 1 minute. So about the hardware requirements, as I said, I'm running all of this on a virtual machine. And the screenshot that I chose to show you here, it shows an interesting incident because the hardware machine, and the virtual machine, it ran into its hardware, I would say constraints. So there's one point where you can see at the CPU usage that there are some yellow bars to it. These yellow bars, I don't know if you're too familiar with Zabbix, they mean I/O wait time. That means that the hard drives, they were basically at the limits, but that was not because they were too slow, that was because the machine began to swap. So it was swapping data. As you can see on the lower end, where the the RAM is running out basically after some time. And then we increased from 2 gigabytes to 4 gigabytes, and everything went well. And sometime later, we even added 2 more cores to the machine, so it's now running with 10 virtual cores and 4 gig of RAM, which is, I think, quite lightweight. So for the receiving side, I said that there's a need to set up a dumper at your end, at the customer's end. For this, I developed also an open source decryptor, which is available on GitHub. This basically is just a tool to decrypt your data, and then it loops it back to your loopback device, and you can pick it up with any tool you like. I was also collaborating together with Paolo from PMACT in order to enable PMACT to also support the kind of decryption, and he did a very good job on implementing this quite fast. And by the recent time, we also have support for FastNetMon also to pick up the encrypted data. And just as an example, you see a short terminal snippet where I am trying all of this stuff out, and this is the DTLS decryptor that I wrote for you, which is listening to the interface IP address and picking up the traffic. And the upper screenshot that you see is, I think it's Elasticsearch or something like that. Just an example for you to show how this might look if you are running this kind of software at your end. There are a couple of planned enhancements to do. Currently, we're exporting only over the standard CFlow port, which is 2055. I want also you to have the ability to change this. And also what people were wondering about is what have they been wondering about, so they don't know what they have been looking into, and then we've got lots of, let's say zombie exports, things that were once triggered but nobody knows about them, and then in the end we've got lots of dead exports that don't do anything but just an artifact in our configuration. So I want to give you the feedback about what you have been wondering about, if you are wondering about what you have been wondering about. Also, I want to enable support for IPv6 IP addresses in order not to force you to rent some virtual machine to get a static IPv4 public address or something. And also there's work to be done for as we call this, global rollout in order to support other DE-CIX sites. Well, technically everything is in place. All I need to do is test it. And there's also a webinar available at the DE-CIX Academy. So to wrap it up, this tool basically allows all of the customers, or all of you, to self-manage your IPFIX collection with a unique vantage point. We encrypt the data for you. You can run your own analysis tools. And as I said, it's a free service. And what is all of this about? If you are a customer, please hit me up if you have problems setting it up. And if you are not a customer and you want to run this yourself because you have IPFIX data in your platform, I'm very happy to share the code with you. I'm looking forward to a lovely round of questions. Do we have any?
Oh, we have a question.
Hi, Frederick, AWS. So as far as I can see, this is filtered on destination MAC address, right? So for example, our MAC address at DE-CIX.
On both of the MAC addresses. So whatever is incoming and outgoing to your interface, yeah.
All right. Because one of the problems that we always have is spoofing on IXs, right? Like there's someone that is pretending to be us at an IX. And this is impossible for us to track down today, right? Because we don't see where the traffic comes from, which MAC address, right? Mm-hmm. So with this tool, it seems that would actually be doable to see which customer port we are seeing traffic coming towards us from. It is a bit complicated use case, but it is very common that spoofers are using our IP addresses to attack us with our own IP addresses. It might sound weird, but that's happening across the globe. So we would like to understand which customer port or customer MAC address, for that matter, that is sending traffic that looks like us to us.
Yeah. So excuse me. There's one thing I need to double check with. You're talking about IP address spoofing or MAC?
Yes. So they are doing IP address spoofing.
Okay. So in case of IP address spoofing, the exported flow data that you would receive from our side would show you the actual customer port which was injecting this kind of spoof traffic, and then directed it to your port. So you will see as a source and destination port, I guess, your own IP addresses, as you said. And you will see as a destination MAC address your own MAC address, and as the source you will see the dubious customer.
Okay, that's very good.
That's part of it. Yeah.
Has there been any plans of this? While I appreciate the whole export of IPFIX data, like that's very good. It's something that probably we could use, but for like a large portion of perhaps your customers, maybe they want an actual interface. Like they maybe can't take the IPFIX stream, but rather just want to see it in the interface directly in the portal. Is that something that's been discussed or on the radar or anything like that?
We have portal insights, we call it the system insights, that is showing you various kind of statistics for your port as a visualized graph and stuff like this. Yeah, DE-CIX also has this already, and we are also using the IPFIX as a ground truth for this, but this is not part of the IPFIX export pipeline. But yeah, these kind of products are already existent. So if you're just wondering about traffic insights and you want to see like in the aggregated form already pre-built graphs, then we have a solution for this. But if you want to have your own analysis tool running on top, or streaming it, or archiving it, or because you want to have it, just have it, then you want to use the IPFIX export.
Yeah, okay, makes sense. Very good. Very good job.
Thank you. I gotta go.
Not yet. There might be another question.
Any more questions?
No. Thank you very much, Daniel.
You're welcome.